Population is the group that you're interested about and the group that you want to find information from. So I want to know what is junior high school 194's favorite music group. So junior high school 194, the whole student body population, student body is my population, right? Now, because the population is too big, right, I'm going to take a sample. So sample is this group that I randomly selected, yeah, and where I'm taking the information from. Okay, so that's sample. Now, sample statistic is, how should I put that? Sample statistic is just statistic. Is the information that you acquire from the sample, like the mean, the median, the mode, um, right? Those are the numbers that you obtain from your sample. Okay, it's the numbers that you generated from your sample. Okay, and that's sample statistics. Pretty silly, if you ask me. Okay, in the context of surveys, how does a random or biased sample um, affect the results? Well, we talked about this. Randomness ensures that the survey that you're doing does not, so randomness, I guess, randomness ensures that the survey, sorry, my handwriting, is not favoring any particular group. Right, so like we set up a few examples in class. If I want to know what is, again, 194 students population's favorite sport that they like to play, I'm not going to just ask the soccer team, right? Because obviously that is going to probably and most likely have results that will say, hey, we like soccer better than any other sport because they're the soccer team, right? So again, you can see that it's a little bit biased. Okay, so the randomness ensures that your results doesn't favor any particular group. Okay. All right, that's that. 3. John would like to find out what percentage of residents in his neighborhood enjoy shopping. So, in his neighborhood, right? So, he wants to find out the percent of residents in his neighborhood. So that's the population, right? The people in his neighborhood. Which of the following is the best method to randomly select participate to take John's survey? So now we're going to take a sample. Maybe his neighborhood, I mean, like imagine Whitestone or Flushing. You're not going to ask everybody, right? So you got to take a sample. So which option has the best chance of being representative and unbiased? So again, um, even within Flushing, there's North Flushing. I guess there's South Flushing. There is a Flushing area where there's uh, a certain group of people that most live there. So I mean, you want to get a sample that is again representative and unbiased. So a group of people that represents the whole neighborhood. John can go to his local grocery store and survey individuals at random to determine if they enjoy shopping. So obviously it's biased because if they're local grocery store, um, they obviously enjoy shopping or they like to go shopping. Local grocery store, it probably favors a particular section of his neighborhood, so it's not including everybody in the neighborhood. I mean, notice that there are several grocery stores within a neighborhood, so you might be favoring a select group here. John can sit at the park in his neighborhood and survey every individual that passes by to determine if they enjoy shopping. Again, people who are in the park um, live near the park, so we're ignoring people who are not around that neighborhood. And again, you're favoring a certain group. Okay. John can number residents in his neighborhood and randomly select residents to survey using a random number generator. I think this says it all, right? Put everyone's name, assign everybody a number, put them in a hat, and then randomly select numbers. And then the people selected are going to be the people interviewed for the survey. everybody has the same chance of being selected. John can go to his local mall and survey individuals at random to determine if they enjoy shopping. Obviously, if they're in the mall, okay, they do enjoy shopping, or at least they are more prone to like it, right? So again, you're it's a certain bias to certain people with interests of shopping. So that would not be the right group. And then last one, there's no effective way to randomly select participant to be surveyed. Of course, that's not it. So this is not it. This is not it. This was not it, and this one was not it. Okay. And just going back here to the park in his neighborhood. Maybe not everybody walking in the park live in that neighborhood. Maybe people come, I don't know, from the next neighborhood to come and walk and enjoy the park. So that doesn't really, we don't really know where these people are from. Okay, that's that. Okay, so again, a lot of common sense, right? And I think it's pretty, so far, pretty simple. Table below shows the height temperature. We want the MAD. Okay, so the mean absolute deviation, MAD, mean absolute deviation, right? Talking about how much data it varies around the mean. How far is it from the mean on average, right? Consistency or inconsistency. That's what the MAD will tell you. So first thing we need to do is find the mean. So we gotta add all these numbers, which I'm doing right now. And I get 1,158. How many numbers were there? 1, 2, 3 divided by 15. So the mean divided by 15 is 77.2. This is, I mean, I can sort of draw, I can draw them around. So what's my highest number? 90 looks like, and what's my lowest number? 79, 78. So I'll do one. 78, 79, 80, 81, 82, 83. You don't have to do this. I'm just want to show you 85, 86, 87, 88, 89, 90, right? So I think a box, what they call dot plot, can show you. So the mean, if I didn't make any mistakes, is 77.2. I'll put a blue flag over here. 77.2. Did I divide? Wait. 1, 2, 3. 1, 2, 3, 4, 5. Okay, it can't be 77.2. Well, because it's too low. What? Yeah, I'm going to try again. 85 plus 79 plus 82 plus 80 plus 90 plus 79 plus 83 plus 83 plus 78 plus 78 plus 80 plus 82 plus 82 plus 86 plus 83. Enter. 1,224. Okay, so 1,224 divided by 15. Hopefully that's a little better. We got 81.6. Right, that seems a little bit better. So the mean is 81.6, and I'll put a little flag over here. Right, that's our mean. So on average, the temperature is 81.6. And how are the temperatures? So I'm going to go one by one. Let me tape orange. There's an 85. There's a 79. There's an 82. There's an 80. There's a 90. There's 79 again. 83. 83. 78. 78. 80. 82. 82 again. 86. And 83. So it looks like a lot of numbers are close, right? I mean, it's not just one that's a 90. So am I expecting a big MAD? Well, let's see. So the MAD, now that you had this, you have to find the difference, the absolute value, distance that these numbers are to 81.6. So I'm going to go this way, okay? And because we're going to have to add them all up. So 85, so 81.6. Imagine you had to walk to 85. It would be 3.4. Plus, if you're in 79, what's the distance from 79 to 81.6? That would be right here, 79 to 81.6 would be 1, 2, 2.6. 82, you're just 0.4 away. 80, I'm sorry, 80, you are, wait, let me just write 81.6 over here. 80, you're 1.6 away. 90, you're quite far. 90 to 81.6, why did I jump? I can use the magic wonder of calculator, that's 8.4. And then 79 will be 2.6. And then 83 will be 1.4. 1.4 again. And then 78, you're 1, 2, 3, 3.6. 3.6 again. 80 to 81.6 is 1.6. 82, you're 0.4 away. 82 again, you're 0.4 away. 86, let's see, 1, 2, 3, 4.6. Sorry, not 4.6, 4.4. And then 1, 2, 3. 83, where are you, 83? 1.4 away. Let me just confirm this 83 over here. 1.4, I'm okay with that. All right, so that seems, unless I made some big mistakes, so now we got to add all that. 3.4 plus 2.6 plus 0.4 plus 1.6 plus 8.4 plus 2.6 plus 1.4 plus 1.4 plus 3.6 plus 3.6 plus 1.6 plus 0.4 plus 0.4 plus 4.4 plus 1.4. Enter 37. So all this equals 37.2. And we're going to divide that by 15. And we get 2.48. That's not bad, right? So the MAD is 2.48. So they're about, on average, 2.48 units away, or degrees away from our mean of 86. Or is it consistent? Can we tell? I don't know. Compare this. Let me change instead of temperature. Let's say there was a game, and this is the number of points a player scores. Okay, so let's change the context a little bit. So do you think it's consistent? So if his average is 81.6, do you think he's going to always come and score around that number? Yeah, there's not too many variability, right? Because the spread, I mean, this 90 makes the spread looks like a little bit too much, but I mean, it was only once that he brought it to 90, right? So most of the time, we tend to, I think, stick around 81.6. Okay, but yeah, that's about it. Box plot. So if I gave you two number lines, just in case there is a outlier. So, numbers. All right, let's do the easy ones. Min 89. That's off the bat. No, that's not off the bat. Sorry. Let me put them in order from least to greatest. So we have 83, 86, 87, 88. We have a 79, which I forgot. Okay, not a big deal. We have an 81, so now we took 79 and 81. We have an 89. We have a 90. We have a 91. We have a 95, 108, 111. Right, so Box plots are easy because it's just a median. So number in the middle, let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We have two numbers in the middle, so the number is 88.5. And we're going to go to the bottom half and look at the number in the middle. And again, it's going to be between these two. Okay, so what's between 83 and 86.5? 84.5, apologies. That's my Q1. My Q3 is going to be, again, between these two numbers. So the simple way to do that is add them up and then divide it by 2. So here we get 93. So there, well, I have my 5 numbers that I need. This one, this one, this one, this one, and this one. So the min is 79. The max is 111. Q1, which is 84.5. The median is 88.5. Q3 is 93. The IQR is Q3 minus Q1. Might as well just calculate all that. So Q3 is 93 minus 84.5. 4.5 is 8.5. And I'm going to draw the box plot without worrying about the outlier for now. So let's put that in. So let me just draw one. 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90. You can go by 5. 91, 92, 93, 94, 95, 96, 97, 98, 99, 100. 1, 2, 3, 4, 5, and hopefully you made it smaller. 6, 7, 8, 9, 10, and 111. Okay, 111. So we need a 79, which is my min. We need a max, which is 111. Q1 is 84.5, so I'm going to draw a line here. There's my Q1, 84.5. The median is 88.5, so 88. So this is 85, 86, 87, 88. 88.5 is right here. 93 is my Q3. There. Let's draw the whiskers. Long whisker here. Let's spread out. And you'll notice that our data here seems to be concentrated to the left here, right? So, no, yeah, that's it. So this it look like it's skewed right? So I mean, think about it. If this was a dot plot, and let me just do a dot plot quickly. 79, 81, 83, 86, 87, 88, 89, 90, 91, 95, 108, 111. Just showing to you that our data, right, and it looks like it's correct. Like 50% of our data is from 84.5 to 93, right, just by looking at that. So these two, or maybe even these two here, do seem like outliers. Let me erase that. So that's your original box plot. Now we got to figure out if there are outliers. Well, let's do the Q3 plus 1.5 DIQR. Q3 is 93. To that, we're going to add 1.5 times the IQR. So 1.5 times the IQR. So 1.5, the IQR is 8.5. Let me just multiply that in a calculator. 1.5 times 8.5 is 12.75. So Q3 plus 12.75. That's going to give me 105.75. So anybody above this number is an outlier. Okay, so on the downside, it's Q1, which is 84.5, minus the 1.5 times the IQR, which is 12.75. So we're looking at numbers on this side, right? So 84.5 minus 12.75 is 71.75. So if you had a value over here, 71, 69, 70. Those would have been outliers, but we don't have to worry about that. So we do have to make a little change. So again, here would be my box plot. This wouldn't change. This wouldn't change. This wouldn't change, and this wouldn't change. So let me take care of that. The whiskers doesn't change. The box doesn't change because none of those numbers are over 105.75. So as we're going, right, the whisker, 105, what's my highest number? Well, my highest number is, so anything above 105, and I'll put 105.75 here. So 111, we gotta take that out. That's an outlier. 108, which is 105, 106, 107, it's also an outlier. So my whisker is going to shorten to the next highest number, closest to 105.75, which in this case is going to be this guy right here, 95. So our whisker is going to shorten considerably. Right, it's going to shorten all the way to here. So the modified box plot looks like that. Without these two, right, that's what your box plot looks like. A little bit more symmetrical, right? A little bit more. Okay. All right. That plot shows the number of public holidays in some countries. So now, before I start this, let me go back to this page. Maybe you guys might want to write this down. So let's talk about. Let me clear that out. Skew left. So skew left. Now, if you notice, right? So here is most of your values, right? So most of your values are hanging out here. And you have like a few outliers in this here, right? So it's definitely skew left. Now, when it's skew left, what happens to your mean because of these guys over here? Well, the mean goes down, right? So that's right. The median adjusts itself, right? This is about the middle of everything. And the mode is the highest, right? The peak, the one that it's at its peak, and that's easy to find visually. So let me change that to skew right. In skew right, your outlier, most of your data is hanging out here, right? That's your data hanging out over here. So mode is still this guy here, right, which is your peak. The median, a little bit to the right of it, and the mean again, because of this guy over here, the means goes on it increases. All right, so that's what happens to your mean, median, and mode when it's skewed right. And then when it's symmetrical, well, when it's symmetrical, right, I mean, if you think about it, if you're symmetrical, that's better. So if you're symmetrical, that's your mode, right? That's your mean, and that's your median, if it's symmetrical. Okay. Then let me go back to this. So this one is definitely skewed. Where is it going? Left. So this is skewed left, which means your data is hanging out here. Find the mean. Well, I'll list the numbers. Plus 13, plus 14 twice, plus 15 3 times, or you can just multiply by 3 instead of doing what I'm doing. Plus 16, how many times? 1, 2, 3, 4, 5. 2, 3, 4, 5, 17 3 times, then 18 twice. Put all that in your calculator, or you could have put, don't forget the 7, I did 7, you can put 7, you can put 7, you can put a 13, you can put a 28, you can put a 45, what is this, times 5, you can put an 80, times 3, you got 51, and this is 36, whichever one you want. Let me add these numbers. Give me a second. 7 plus 13 plus 28 plus 45 plus 80. 1, 2, 3, 4, 5 plus 6, enter. So the total is 260. I'm going to divide that by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And the mean is 15.29 rounded to the nearest hundredths. Okay. The median, number in the middle. So again, if we cross 1 from each side and keep walking, right? 4, 1, 2, 3, 4, 1 from here, 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 and obviously the median is 16. The mode is the peak, right? The mode is the peak here, and the peak is 16. What's the range? The range is 18 minus 7, which is 9. How would you describe? So this is skewed left. Which one describes best? Which measure describes best describes the data above? Definitely the median because of the median. Because of the what? Of the outlier. Okay. All right, we're almost, and we're gonna take a little commercial break. No, I'm kidding. We're not taking a commercial break, but we're gonna talk about the website. So the name of the website is More Than Yesterday. One day I'll explain. So it's, to be honest, I always make my own websites, and I know I told you guys this earlier in the year, but this year they had this one, jhs194.org. So remember I told you the school decided to do this for us. And staff website. So if you go here, you'll find. So I just made this one, right? So the idea was for me to stop paying the $20 I pay every month, right, and just do this. But which I started, and as you can tell, you guys, I put all this. So as I was working on it yesterday, I wasn't too happy with how he was allowing me to put certain things. It drove me a little crazy, to be honest. So I went back to my own. The company is called YolaSite. So I picked the name More Than Yesterday. Alexa, stop. So it's the same thing. I'm so much happier right now because I obviously have been doing this website for 8-9 years. So I know how to input pictures and formatting and everything. So again, you guys are going to be here, 721. This is again the quiz review. So a little bit later when I upload the video, you will see this, and then on the right side here, you will see the video. Okay, so I'm just so much happier doing this. Hey, so it's personalized, it's mine. I can, and this is 701. So here we have questions. I put some links or files to previous year's state tests when it comes that time of the year when you want to study. Regents resources, which you're going to definitely be using even this year. SHA, specialized high school test, practice tests. Okay, you have the links. You have let's see, state test questions by standards. Again, once we get to that part when you want to study, so let me click on this one. Again, you can see previous years and based on the standards, which we're going to do anyway. So again, the name of the website is More Than Yesterday. Last year's was, what was last year's name? I forget. Nonlinear Thinking. Every year I try to come up with something. So again, the name of the website is More Than Yesterday. And yeah, that's pretty much it for that. So I'm going to start. You're going to start coming in here, right? And then if you're absent, I mean, I guess I still put it in Google Classroom, but mostly you'll come. I like to put it here. This is where I would come first, and then I would put it on Google Classroom. Okay. yeah, that's it. So let's go back to where we were. No. This, yes. Okay, so here's a population question sample. The population is junior high school 194, and we wanted to know what is everyone's favorite subject in school. So too many students for me to ask one by one. So I took a sample, which I randomly selected 120 students. So the population was the students at JHS 194. That's the population. My sample, which I randomly took, were 120 students. My sample statistic, right? Statistic, right? So information that I generated based on the sample, right? From the sample was that 84, and I don't know why I'm putting lines, but it came out that 84 out of 120 students, right? 84 out of 100 had social studies as their favorite subject. Okay, so now how can I use this to sort of see if I were to if I had to ask 935 students, if I were to ask, what can I expect based on the sample that I took? So assuming that the sample represents the population, right, fairly, right, then I should get the same result. So 184 out of 120. So let me see. If you divide that, 84 divided by 120 just happens to be 70%. So in my sample, 70% of the students said, I like social studies as my favorite subject. Which means that in my population, if my sample here was reflective of the population junior high school, right, then out of 935 students, 70% of those students should also say that we like social studies as their favorite subject. Should. It could be, there's a obvious percent of margin of error plus or something, plus or minus, however. But that's another conversation. So how do I use this? We can set up a proportion. And we can say, well, here, right, the total is 934. So how, and we can call it X because out of 120, 84 like social studies. Out of 934, how many will like social studies? So you can cross multiply here. Right? You can cross multiply these two. 120 times X is 120X. 84 times 935 will get you some number, which we'll figure out right now. So 84 times 935 is, sorry, 84 times 935 is, get glasses, 78,540. 100x, right? So again, one-step equation, we want to isolate our variable, so we divide the side by 120, and we divide that by 120. That simplifies to 1, and then that number divided by 120. So the actual answer is 654.5, right? So, but in the context of our story here, we can't have 654.5 students, so the answer will go to 655. So out of 935 students, we should expect 655 to say we like social studies. That's one way of doing it. The other way was what I mentioned before. So in our sample, we found out that we found that 84 students out of 120 like social studies. So if you divide that, you get 0.70 and 0.7, right, which is percentage-wise 70%. So that ratio should also be reflected here. So 70%, so we can actually write 0.7 of 935, right? 70% of 935 will also like social studies. So if you multiply 0.7 times 935, get the same exact number, which is 654.5, or you round it to 655. So if you set up a proportion, which I think you're probably more familiar with, or do that, use the percent. It doesn't really matter. It's really, really up to you. The last question. So, how do you see this growing? So we have, well, I know we're talking about circles, and determine the number of circles in 85 terms. So there's 4 over here, 1, 2, 3, 4. Now these same 4 repeat over here. Actually, let me do this. This is my first term. This is my second term, my third term, my fourth term. So you ask for the 85th term, and then the nth term. Right? So I see that there's these 4 here in the first term. In the second term, these 4 are also present. And again, whichever way I'm using here, it's just one way. You can see it in so many different ways. Third term, those 4 are present. In the fourth term, also present. So if I were to draw the 5th term, just out of curiosity, I would have those 4. 1, 2, 3, 4. Those 3 present, right? And then how would I adjust? So seems like I always have, so in the plus 4, so it's 4 plus whatever. And then what do I have here? I have the 4. So here I have 4. Then I have those 4, and I have 3 more. Right? This 3. Here I have the 4. And it really, let's see, how do you see it growing? The 4, and then I have these 3 plus 3, and then guess what? Another 3. On the fourth term, I have our original 4 plus these 3, right? That's how I see it growing. Plus another 3 plus another 3. So if I were to draw the 5th one, I would have, let me just draw it a little better. If I were to draw the 5th one, I would have my original 4. 1, 2, 3, 4. Right? And then I would have 1, 2, 3. I will have another 1, 2, 3. And notice now, if you think about this, the number of 3's that I add on to, here on the second term I added 1. So the third term I added 2 groups of 3. The fourth term I added 3 groups of 3. So it's always 1 less than the term. So in the 5th one, I'll change colors. That's 1 group, 2 groups, 3 groups, and 4. So it's going to look like a 4 plus this 3 plus this 3 plus this 3 plus this 3. Now, how do I write that? How do I write that? Well, let's see, how can I write that? So I can write, it's always going to be plus 4, something plus 4. So how do I relate the term with the groups of 3? So it's 2 times 3. This one is 3 times 6. 4 times 9. 5 times 12, or 5 times 4 times 3. So it's always going to be the term. So let's see. So if we talk about the nth term, 1, 2, 3, 4. Here's the square. So we know it's going to be a 4 plus, and how does this, whatever this number is, the 6th, the 7th, the 8th, relate to the number of groups of 3, which is the way I did it, right? And that's a good question. So 2 groups of 3, so it would be n minus 1, right? So because when there's 2, there's only 1, times 3 times, does that work? So why is it n is these numbers over here? N is these numbers. So if I take 2, because there's only one group of 3, right? So it's 4, so think about it. It's 4, let me rewrite this backwards. So it's 4 plus something multiplied by 3. So in this case, when it's the second term, right, we only multiply by one group of 3. So when it's the third term, it's 2 times 3. When it's the fourth term, it's 3 times 3. So it's always one less than that particular term. So I'll represent that term like that. Let's see if that works. So if it's, and then let me do the total for now. So that's 4, right? So the first one is 4. This one is 7. This becomes 4 plus 3, 6. This is 10. This is 6, 10, 13. This is 6, 10, 16, and so forth, right? So let me plug 4 in my little formula over here. So if I plug 4 in my formula, I should get 13. So I get 4, right? That's the original 4 plus, and I replace the n with 4. So I get 4 minus 1 times 3. Now 4 minus 1 is 3. 3 times 3 is 12. Sorry, 3 times 3 is 9, plus 4 is 13. Yeah, look at that. It does seem to work. Don't you think? So if I'm going to try here the fifth term, so again, let me erase this. Here's my formula. And I'm going to replace that with 5. So I get 4 plus n minus 1 times 3. And I'm going to take this and replace it with 5. So I get 4 plus 5 minus 1 times 3. Let's see if that works. 4 plus 5 minus 1 is 4. And then we're going to have to multiply by 3. 4 and 3 is 12. Plus 4, 16. Okay, so again, yeah, that's it. So that's one way. That's one way. That's how I saw it growing. Okay, and that's how I got my, this is the nth term. So now, if your math teacher says how many are in the 85th, how many circles are in the 85th, let's calculate that. So it'd be, copy the expression that we came up with. So it's going to be 4 plus, what is it, 85th? So here, 85 minus 1 times 3. 4 plus 85 minus 1 is 84. We got to multiply by 3. 4 plus 3 and 4 is 12. 24 is 252 plus 4. And we get a total of 256. So on the 85th term, we need 256 circles. Okay. Yeah. So, yeah, that's it. All right.